Take the floor. Nice to meet you.
Thank you very much.
Can you please put his presentation? Yeah, okay, so you have the floor.
Yeah, thank you very much. Can you hear me? And this is the control.
Okay.
So, hello, thank you very much for coming and listening. This is Mete Kavuncu from Nokia. I'm an end-to-end solution architect and CTO for selected customers.
I thought it was with the phone.
Is it better now? Can you hear me?
Yes.
Okay. Today I will talk about a concept or a vision called FutureX Network. It's presented like a reference architecture for digitalization of networks and communication service providers. Let me try to explain and summarize first what I'm going to talk about. I think I have half an hour, but we are a bit ahead of time. I try to fit it in that one. If you would like to discuss some of the topics, we can of course reserve some more time. In short, I'm not an expert of quality of service or quality of experience, but I was invited to this call to describe this future vision of the networks, because things are changing, world is changing. Now we are observing that to be able to live in this world, you need to get digital. Digital service providers will survive this change. And if they do not change, they will just disappear. Change is mainly about us, about our lives, about how we do things, how we connect to each other and to things, and how we interact with each other and our environment. Our lives are going to change because it's a revolution. And to be able to understand how we need to transform ourselves, our networks, we need a model. Nokia Bell Labs have built a model which is called FutureX Network. I will try to describe what it is in more detail in a few seconds. And of course I will talk about the implications of such a network on the customer experience and the service quality. What needs to be done over there. I understand that it is a bit ambitious for half an hour. However, I'll just walk you through a couple of slides. I have like 10 or 9 slides. I will try to spend most of the time on the architecture of the network, which is my subject area, which is my domain. So, let's continue. Oops. Okay. So the world is changing. We are now in the doorsteps of the 4th Industrial Revolution. The 4th Industrial Revolution can be described as a fast-moving, digitally connected online environment with some enabling technologies behind. I guess we are all familiar with the concept, therefore I will not go into what is this and what is that. There are enabling technologies like artificial intelligence, Internet of Things, robotics, autonomous cars, clouds, virtualization technologies, and 5G. But the implication for us, the more important thing for us is that in every revolution, some of the players are disappearing and some new players are coming in. So maybe you will be surprised to hear that some of the Fortune 500 countries from the previous industrial revolution do not exist anymore. They just gone bankrupt. Right? I give you one example, not from this part, but it's an example from here. From the first industrial revolution. Have you heard a guy called Joachim Slocum? Joachim Slocum. Maybe not. Are you interested in sailing? I'm interested, so therefore, and I'm a white-collared skipper sailor. Therefore, I cannot make too much experience. I read a lot of books. One of the books is about Joachim Slocum, and Joachim Slocum has been a captain of sailboats, commercial sailboats, before the first industrial revolution. One day, he suddenly lost his job because the steam engine was invented and it was incorporated into the sailboats. And suddenly, because of this technological advancements, the commercial, traders just decided that it is much convenient to give their commercial goods to a steamboat instead of a sailboat, because it was much more reliable and it really changed their lives and it really brought them more profits. And Joshua Slocum suddenly found himself jobless. And he was still young, just at the age of 50s, like myself, and he decided that he just would buy a boat, an old boat. He restored it, and since his wife didn't want to accompany him, he started his journey alone around the world for the first circumnavigation by sail of the world, with a single-handed man, only one man. Right? His book is very nice. I recommend to read it if you're interested on this one. But it's just one example, and it happens also here. Now, as we are observing, the over-the-top providers are really threatening communication service providers' situation, and also it's a threat for the vendors. There's a major change. There's a disruptive change in the industry. Our lives are changing. The fourth industrial revolution is changing our lives. And who will be the players of this next industrial revolution? 5G is the next technology. One of the operators have put into their explanation of why 5G, and one of the reasons was that okay, the previous G useful lifetime has expired. We need to find a new number, and we have to go for a new generation. But I will not repeat the famous triangle. It's the useful triangle. Yes, it's based on the use cases. Yes, it supports diverse use cases. However, the more important thing about 5G, in my opinion, is that it is an ideal. It's a study to really enable the change of our lives and industries, so that we need to build a foundation which will enable our enterprises, our service providers, our people, our companies to really change the way how they interact with each other in a meaningful way, so that they do not spend unnecessary time, workforce, and money on the unrelated stuff. But with these technological advancements, we can leave most of the unnecessary stuff to computers, to artificial intelligence, robotics, virtualization, and all the other stuff, so that we spend our valuable time over there. So 5G is a combination of technologies, but it's an enabler for us, in my understanding, to be able to change the lives. Okay? And just a short slide about the comparison of communication service providers and the digital service providers. We said that digitalization is now coming. There are several different descriptions for digitalization. Most probably all of us have already one and have understand this one. But I would like to not define specifically the digitalization. However, look at the outcome, look at the impacts of this one. If you look at a traditional communication service provider, they define themselves to provide the access, and they put most of their investment on providing this access, either fixed or wireless. On top of that, they put a robust network where they have this core network which is switching into transportation and all the other stuff. Then they put some applications, and on top, they provide an experience which needs to be maintained. But the core business is that they are providing the access. However, when the challenges came, like the over-the-top providers, the digital service providers, they did just the opposite. They more or less didn't invest anything on the hardware. They didn't put anything here. They just rented some software to be able to change it easily. And they maybe bought some network equipment and that kind of stuff. They invested much more on the applications, and they invested much more on the autonomous story. But most of the investment is about the experience of the customer. They invested a lot of money, they invested a lot of time, and they invested a lot of thought into this, and they concentrated on this one. And their core job is not here. They don't have any assets even. Their core job is the customer relationship and the customer experience. I think now this is not a technological story. It's not my topic. Most probably there are no sociologists here in the room. However, it is like a social story, but it gives us a hint that the change from a communication service provider or a digital service provider is not only on the technical side, however, it's on the mentality side. It should start from the mentality side. And one of the definitions says that giving the control of the business to technology and to artificial intelligence, maybe could be on that one, But one important aspect is that you need to be able to change everything based on your customer experience. Therefore, in my understanding, customer experience and customer service quality is in the heart of this digitalization. Now, the scope and the topic of this group is, I think, coinciding, intersecting very much with this one. So, a couple more slides about the digital transformation. What is a digital transformation from a conventional provider to a digital provider? So, it is defined as a digital transformation, defined as a business-driven initiative that marks the beginning state of continuous change. I think it's a very vague description. However, what I would understand from this statement is that you need to be able to change always and rapidly. It's like a foundation of being a digital service provider. So there's no core job, there's no core asset. You should really forget about all of them, and you will concentrate on what your customer needs, really, how you can change their lives. So improvement is needed at all levels in an enterprise, being a service provider or being a factory or being a hospital, right? And you need to keep pace with the customer demands as they want, as they wish, and you need to improve their experience and their. And of course, I will try to avoid spending too much time. There are a lot of dimensions. However, I think the most important dimension of this one is that it needs to have a measurable quality of service and quality of experience benefits. Whatever change you are doing in your company has to result in a positive change in the customer experience and customer service. Right? And if you look at the visualization, the customer relationship is on the center of a digital transformation. So everything is served, the organization, culture, business strategy. What's your business strategy? Our business strategy is to provide access. No, it's not. Your business strategy is to provide the best experience to your customer, right? And you can change everything. You can change all your personnel. You can change all your network. You can just change everything. But you need the tools and skills to be able to do that. What does it mean? So you need to always be able to get in touch with your customer, and you need to empower your customers to change the service they are getting, to change the level of the service, to change the type of service they are getting from you, and you should be able to provide it as well. And you have to change your operations and business processes accordingly, all the applications, and of course you need to have a network which supports this mentality. So this is now coming to my topic, coming closer to my topic. And what's a digital service provider? Again, final slide on this one. Again, a digital service provider is a provider who has a customer-centric business. The core business is to provide experience to the customers, right? There are many dimensions, but the most important thing is to empower the customer about what he gets from you, how he gets from you, in what quality he gets from you, she gets from you. Okay? And digital service providers generally, and they have to, because the industry is going on that way, use a cloud-based infrastructure, a virtualized infrastructure. They don't really invest too much on that one, and because they need an automated and agile business processes, and they want to reduce the cost of service delivery. They can come from different backgrounds. They can be a communication service provider, cable provider. They can be an over-the-top provider. And even they can be coming from any other dimension, and they do not own any assets, but they just make the connection with the right partners for their customers in a big and useful ecosystem. That's also possible. Okay, so these are the aspects of being digital. However, as I said, for our context, for a service provider, you need a network which enables you to be such agile, such dynamic, and such close to your customers, and which enables you to empower your customers to do that. And for this, of course, there are several aspects. In my context, I would say that Four are most important. Like your experience, of course, customer experience is the most important. Then you have to be ready to change the business, and you have to start transforming it. Details can be read from that. I want to reserve the time to talk more on the architecture, therefore I'm just passing through this. Operations are most important. However, operations needs to be automated. Manual operations will be here in this one. And of course, you need a network which will enable you to deliver these services. And now, this is my topic, this is my comfort zone. However, at the first glance, it looks a bit complicated. Are you familiar? Has anyone seen this before inside the room? Okay. This was created by Nokia Bell Labs. The name of this reference architecture is Future X reference architecture. Future X. Why Future X? Because it gives you a guideline and a vision on how a network should evolve from today in the future to enable a digital service provisioning, and also to give you the opportunity to change the way how we interact, how we connect, and to serve any use case, to connect anything and anyone to each other. Right? It's a future network, and it's for anything, for any type of connection, for any type of experience. So, of course, it's a complex stuff. Even abstraction and simplification of this kind of model network looks complicated at the beginning. It goes on 8 levels, starting from 1 to 8. I will go one by one, starting from the first up to the 8th. So try to stay with me, and in case you have any questions, you can interrupt, we can discuss over there. I will make references to many discussions and presentations which we made yesterday while going through this architecture, because there were a lot of questions related to this one. So, the first domain of this reference architecture is the massive scale access. So, in our next network, in our future network, as described in the 5G triangle, we need to have we need to support a massive scale access, being mobile or fixed or whatever. But we have to understand that we are not only connecting now people, human beings, but now we are connecting things. And things are really, really massive. The number of things are really massive. One of the implications of this one is that when you are talking about a very big number of things and people connecting to the network, it is not easy to statically design and optimize the coverage and capacity of this network. For instance, you can build your network. Yesterday we had this Sri Lanka example. They were taking this, I don't know, my colleague is still here, but they were taking these weekly measurements and getting an average of the measurements, and then they were looking and they were checking with the reference week if the traffic has increased or gone down or whatever. And they were sending the instructions to the organization which is responsible to make an optimization of the network. However, in the future network, one day you will notice that a new factory has switched on 3 million sensors in one cell only one day. So it's too late if you are aware of this after 1 week or after 2 weeks, and if you try to adapt this. So you need to build a mechanism that this network will optimize its coverage and capacity by itself. Right? And since we are talking about the massive scale access, and we are talking about mainly small cells, even including Wi-Fi's, then we will have to go with a very granular distribution of our access points, which means that this is also part of the number 1, which means that we have to use very long fibers towards the edge, and then at the edge sites we can connect to our subscribers or base stations or buildings with short waves or wires for the remote access sites. So this is one dimension. Okay? A second dimension is the converged edge cloud. Yeah? The access will change in this way, and our cloud, our data centers will be converged, will come to the edges in the name of converged edge clouds. Which means that we have discussed this yesterday, this multi-access edge computing systems. Because of the low latency requirements of 5G, we have to come closer to the edge of the network, right? Because we are limited here. If I have an application, critical application, latency critical application, and even if I use the fiber, I have to go towards the center of the network, I'm limited with the speed of light, right? If I want to go down to 1 millisecond latency, I need to bring the processing, I need to limit the distance traveled by the light to have this 1 millisecond latency. First, of course, I need fast machines, but I need a long distance. Therefore, I have to bring the processing of the application to the edge of the network. It's a multi-access edge computing platform. Plus, I have to bring the switching capabilities, either only the user plane or control plus user plane to the edge of the network. So, which means that, of course, I will have a central core network on my central big data center. However, and this will be virtualized and this will be cloud. However, I have to bring some of the computing and switching capability to the edge of the network. Therefore, I need a converged edge cloud. It will converge the IT and telecommunications needs, and also it will converge the fixed and mobile needs. And you will see that by time, these clouds will be so distributed to everywhere because of our 5G ambitions. We will have too many base stations and too many edge sites. It will become not a cloud, but you will see that it will become like a fog, right? Rather than a cloud, you will see a fog architecture in this. Okay. Now, why I'm telling this? Because this fog will cover everywhere, and the traditional. I'm now coming to the next level, smart network fabric. The traditional spider web like transport architecture will not be visible or will not be able to cover this kind of fog, right? Therefore, it becomes, because there are too many edge sites and too many base stations, it becomes like a fabric rather than a spider web. So it's like covering everywhere. And this kind of architecture is very complex to manage manually. Then you need a smart network fabric, which is based on a software-defined network, and it has to be managed end-to-end, and to some extent it has to be managed autonomously. Okay. After the smart network fabric, which is, of course, I can make a reference to our yesterday's discussion about the front haul, back haul, mid haul, and the backbone network. It becomes a complex architecture, and it also brings a convergence of the fixed and mobile network backhauls. Yesterday, it was also described by Türk Telekom that Türk Telekom would like to consolidate and converge their transport networks as well. The next level is a universal adaptive core. Of course, we will need a core. However, since everything is going now onto the IP domain, we do not need separate core networks. 5 minutes left. Okay, sure. 1 minute for each of them. Okay, so we will need access agnostic converged core on the center of our network. However, the major change which is going to happen in the adaptive core is that it will be composed of modular decomposed network functions, because we need the agility and we need a flexible dimensioning of this core network. Apart from that, we will have a common data layer, which means that all the network functions and all the applications will use the same customer data, and therefore it will bring a uniform, seamless experience to the customer, so that regardless of their access type and regardless of the application, all will have similar data. And even furthermore, we will go into stateless or state-efficient network functions, which means that the network function, let's say it's a core network, it's a packet core network switching function, will not be aware of the state of the connection. The state of the connection will be kept again on this common data layer or shared data layer, which means that in case that network function for some reason goes down or for some reason is taken out of the network, another network function can just go and query the state of that connection and then continue from where it left. It just removes the dependency on states of the function. And on the next level, we will need a programmable network operating system. I think this part is the heart of a future network, because when we are building and implementing this programmable network OS, we will use the network function virtualization, software-defined networking technologies, and we will have a management and orchestration domain, which will enable us to do one important concept called network slicing. This was also discussed in yesterday's presentations. However, as we know, network slicing means that we will build such a flexible network based on modular network functions, which can be automatically chained to bring a different aspect of this network on a single domain. So, in practice, what will happen? We will have a data center, we will buy common off-the-shelf hardware, then we will buy virtual network functions. It's just a software license. We will install the software and we will put it there and we will manage it according to our needs. If we have enough hardware capacity, we will not be waiting for ordering new hardware and new network function, physical network function from anywhere. We will just install new licenses and then we will scale in, scale out according to our needs. And by software-defined networking, we can make a service chaining so that we can build different services. And by multi-tenancy, we can use the same virtual network function in isolation, like a virtual private network, for several different tenants, which means that I can slice my network according to different needs. Let's talk about verticals. Let's use IoT cases as an example, or 3 different use cases of 5G as examples. All have different requirements. Some of them are heavy on signaling, some of them are heavy on traffic. And we can make a slice which is optimized for ultra low latency use case. We can make another slice for extreme mobile broadband. We can make another slice for IoT. In IoT, we can make different slice for different verticals. For vehicle to X, there is a different requirement. For smart city, there is a different requirement. For vehicle to X, we can make horizontal slicing. For Chevrolet, we have another slice. For Toyota, we have a different slice because they have different requirements. Okay? And this means that we are building one single network which is doing more or less everything. However, if we think about the opportunities, this is endless. Probably after such kind of a network which is slicing enabled is built, you will find out that there are hundreds and several hundreds or thousands of different tenants in this network. You can even rent your network to another virtual network operator, and they can also build some other slices on that network. Right? So this is becoming a very, very complex environment. It gives a big advantage. You can optimize your network dynamically on the go. However, it becomes very complex to manage. Therefore, you need to build the mechanisms first to analyze what's happening intelligently in your network, and then to act accordingly if needed. Another point is there, so you are getting this kind of flexibility in your network, but you have to empower your customers so that they can manage their network as they wish. Therefore, you have to provide open APIs, application programming interfaces, so that your users, your customers, your tenants, or whoever can go and change their network configurations dynamically when they want, as they want, and they can change the SLAs. And to be able to manage this kind of network, you really need intelligence in your network, and it should be intelligence and automation in your network. Then you need some artificial intelligence and machine learning. Of course, definition of artificial intelligence is also a bit problematic. There's just one funny definition. Artificial intelligence is something what computers cannot do, right? Like, which means that whatever computers cannot do, you try to build it into computers, and computers can do it, and it's no longer artificial intelligence. But I think there are 2 important dimensions for artificial intelligence. One of them is adaptability. An artificial intelligence system has to adapt to a changing environment and changing situations. Second, autonomy. An artificial intelligence system has to autonomously change the state of the network, it has to autonomously optimize the network whenever it is needed. And I think most of the customer experience will come if we are able to implement such an intelligent and such a capable mechanism here on top of this one. And you are getting a lot of data towards here. Some of them are network generated data, some of them are coming from people, some of them are coming from sensors. And then afterwards, there's a lot of information here. And information is money if you are able to use it intelligently. And on top of this augmented cognition systems, we have the level 7, digital value platforms will come. And if you remember the triangle, the type of investment and the type of, so it is also true here. Most of the money, most of the profits will be generated here on the place where you collect all this data, when you build all this infrastructure, and when you collect all this data, and also you get some external data which is not available in your network, and then put them into a context which is valuable for someone, then it really can earn you some money. Therefore, in case a communication service provider is becoming digital, I think it's important that not leave all the space to the over-the-top service providers, so that over-the-top providers are collecting all the money again from the network that you are not having. Most of the money will be there. And last, but not the least, maybe most important of all, this kind of network is very comprehensive, everything is there. And if you lose it, or if you have a compromise on the security, on the privacy of this network, then everything will collapse. So therefore, a dynamic data security has to be built from the beginning in such a network. And it will require a new trust framework, it will require a secure ecosystem sharing, and it will require mass edge monitoring, because you don't know who is coming and going into this network. So it will require a different perspective from security point of view. And this is, in a nutshell, FutureX architecture. My last slide is about the evolution. So this is the future, and in the short run, how we will go there. Today we will have this 4G LTE networks, where we have the access side mainly, and we have the central side. This is our LTE, the applications and content sources residing on the center. The next step, as described yesterday in presentations, is introducing 5G new radio in a non-standalone architecture. What does it mean? You will have a new radio with higher capacity. It will transmit the user plane directly on itself. However, it will still need the LTE radio for the control plane, and it will still use the LTE core in the first step. Of course, you can introduce the Cloud RAN for some low latency applications. And the next step in 2019 will be the standalone architecture. You will select one of the options, and there you don't need the LTE core anymore, but you will introduce your new core, and you do not need the LTE RAN to transmit your control plane. Your Cloud RAN was already here, but you will introduce the multi-access edge computing platforms onto the edge of the network. Some of the applications and contents will remain here, some of them can go to the edge. And then the final step, I don't know if you can see, but it is the full 5G architecture, which is including the network slicing. Because I think new radio is the easiest part of the 5G network. However, the more difficult part will happen in the core part, because the environment which I described you in the previous slide is really difficult stuff. And yes, slicing in theory sounds very good, but if you need slicing, it has to be end-to-end slicing. And in a normal network, there will be a lot of vendors, and it's a multi-vendor, and this interoperability will really take time. It will happen, not from today to tomorrow, but this is the last stage. And we will see that the core network elements is undergoing a distribution. They are going from the center to the edge. And then we have to build and modify our smart network fabric as described in the previous slide. Then we will see a centralization of the RAN from the access points to the edge data centers for the sake of economy of scale, because we want to share the baseband units here, because there will be a lot of traffic over there. And the separation of control plane and user plane will happen, and the network slices will come there. The applications and contents will be more distributed to the edge of the network. And the more important and the most important of all, to manage such a complex structure, you have to build a real good analytics engine, and you have to build a really good automation mechanism to this one. And this is the mechanism which will ensure that the customers are really empowered and they are having a good experience with your network. So this is like a step-by-step evolution scenario in my context, in my understanding, based on the FutureX network evolution. So this was a slide already shared yesterday by Cesar from Türk Telekom. I will not go through this one. However, I think the 5G quality of service architecture is really changing from this static to flexible, adaptive, dynamic, and quality of experience center operation. And if I summarize what I have said so far in like a few sentences, I know that I'm already over time, but thanks for bearing with me. So the world is changing. It's not only a new technology introduction, but it will change everything. To be able to stay in this new world, we have to digitize ourselves and our operations, all of us. And it will require a flexible architecture for this one. Right? And this flexible architecture is designed for only one purpose in mind. It's providing the quality of experience, and it's empowering the customers. And in such a complex environment, my vision is that it will not be possible to handle that manually. So you have to build the intelligence and you have to build the automation to be able to provide this quality of experience. So this is the end of my slides. Thank you very much for listening.
Thank you very much, Matt. I'd like to open the floor for some couple of questions. Please, you have the floor.
Yeah, sounds pretty complex and challenging. So how do you see the interfaces on the OpenStack mono architecture? Are those standardized and clear enough to have the multi-vendor setup, or is it so that you need to just go to Nokia or Huawei and then you are there?
I think that's a good question. The Etsy Mono has really served the purpose, and I think more than that, the open source software in this OpenStack has proved to be very useful. Now we are seeing on the field that Etsy Mono architecture is really useful to enable the multi-vendor environment. However, as always, it's not straightforward. The first implementations have shown that you need to still have a lot of testing and modification to be able to provide that really multi-vendor environment. So let me summarize how I understand this one. So the ideal is that you get hardware from somewhere, you get a virtualization infrastructure from somewhere, you put virtual network functions from different other vendors, then you get a virtual network function manager from someone else, and then they all work together. I think, yes, it may happen one day, but it's not today. It happens, you can make it work if you have a competent workforce, but you really need to put a lot of efforts. Some of the operators are trying to go this way, like AT&T. They are having a big R&D organization which is working on this one. They are trying to get all the best of the breed. Some of the operators are trying to build a standard environment for virtualization, and they are getting one by one virtual network functions to run over that one. And some of them, to save time, are just giving, as an initial step, like a turnkey virtualization environment with all the most of the VNFs, and then afterwards selectively replacing the VNFs. So that's a pragmatic approach. But I see that Etsy Mono architecture is certainly working. However, it doesn't work like this. We really have to push.
Okay, thank you. Good answer.
Okay, another question? I have one, but let's just see.
I mean, this was a very future-looking presentation. It was very interesting. So one question questions. And so now, let's say multiple operators, multiple countries, each have their deployments. There is a bit of RAN sharing and so on. How do you see this future network very dense? Will it be one network per country? Will it be a common infrastructure? I know from Nokia perspective, it should be as many networks as possible, but would it be realistic to deploy such a dense networks where each operator has their own?
Okay. I think this is also very
Futuristic.
philosophical question, right? If there are regulators, representatives, right? If the regulators are pushing in that direction, it will certainly happen because operators would like to economize, right? They would like to save from capex and opex. Certainly, if regulators allow or push in that direction, it will happen. But on the contrary, if the regulators are pushing on the other direction, so build a better network, serve better your customers, it's still feasible, then it will not happen this way. I think this is more philosophical and regulatory. But operators would prefer to have a single network because there is a lot of investments.
Vinicius?
Thanks. Congrats on the presentation. I'm really impressed about the future of the network. My concern is about, I work with risk management in Anatel, in the regulatory body. And we work a lot nowadays for ensure the safety of the physical infrastructure. For the future, I check, we must prepare for the cybersecurity or anything else. My question is about the security of this visualization slides and how did you say, I can contract cloud from one, the management from another. How can you organize orchestration of this about security?
Yes, I think that's a clear problem. That's a clear problem for the future. Because one of the basic mentality ideas behind this virtualization is that so you are having different places, and also even there are more interfaces, more third parties, different ecosystem. So everyone will come and everyone has to come, because with newcomers you will have a richer environment and you have more value created. And that's why I was telling the most important of this future vision is the last one, 8. If you do not build this security from the beginning, then it will be very difficult. So with a physical security, you will never be able to do that. You will never know in the future if one network function you is deployed here today in your data center is still there, and if there's really a firewall over there. One day you will certainly notice that network function has been distributed into several different places, right? Then it has to have a different built-in security mechanism. And honestly, I don't know how it will be built today. But we just need to understand that, yes, this is one risk. Of course, every data center has to be secured physically by itself. That's true. However, will it be always possible for these edge data centers? In the future, do we know if we will have customer deployed data centers where we don't have no control? Maybe you will install a data center in your laptop one day just for one application, and we don't know how it will be secured. So therefore we need to build a different thing. I think it's a very good question, it's a very valid question. However, I'm not the expert, and it's one of the most difficult questions for today.
Very good.
Okay, actually I had a question on the regulatory implications on this scenario actually, but I will approach you afterwards and we can discuss for the time's sake. I just would like to really thank, it's a very interesting presentation, and ITU has a recent initiative on a focus group on it calls FGNet 2030. It's a focus group of to discuss technologies of the that will be used in 2030. So hopefully Nokia would be involved, and the first meeting, if I'm not wrong, maybe Martin could explain. I think it's the next month in New York, but Martin?
Correct. I just checked with my colleagues in Geneva, so we will meet early October in New York, the New York University. And Nokia will be represented through some of your colleagues, I guess. Think it's going in the same direction as your talk, some network, NetX and Network 2030.
Yeah. Thank you, Martin, and thank you again, Matt, for your very interesting presentation.
Thank you very much for giving me the question.
Let's just jump to the last one. This is a presentation.